to be doing estimating from a sample the population proportion. And I'm going to create a question from scratch, and we're going to go through all the major kind of situations that are involved, kind of make it like a mega question. And then we're going to go and we're going to look at some of the homework examples of that, right? So let's suppose that we conduct, excuse me, somebody else just came in. Let's suppose we're going to do a clinical trial. And in this clinical trial, we collect a sample of 250 volunteers, and we give them a new pain medication. And we just ask them, did it make your headache go away in half an hour, right? So this is a pill that you take if you've got a headache, and it's meant to work inside 30 minutes, right? That's how they're going to advertise it, you know. Take Robertson's pill, headache gone, right? You take one of these, 30 minutes or less, your headache is gone, right? That's how they're going to advertise it. And so they did a little experiment, and they got 250 volunteers, and they said, you know, when you get a headache, whatever, you know, maybe next week, maybe tomorrow, take the pill and tell us if your headache went away in 30 minutes. And 150 said, yeah, we took a pill and it went away. And we would like to find out how effective that would be. In other words, we are going to try and find P. What would be the effect on the entire population, right, if we did this? It's essentially a pretty standard question. And we are going to do it in a number of ways. We are going to find a 95% confidence interval. We're going to find a 90% confidence interval. And then a 99% confidence interval. And then we're going to see if we can put a percentage on what percentage of the population does this headache pill really work for. Now, all the information that I need is essentially here, and we're not going to do it the numerical counting way, right? Where you do the p hat, 1 hat, and all the square root stuff and all the calculations. We are going to do SALT, right? So I'm going to kick over to SALT, and we're going to go through this guy as soon as I figure out where it is. Here we go. Are you looking at the homework questions? Right. So I'll hit SALT and I'll bring it over here. Here we go. And we are going to find the 95% confidence interval first. Okay. So it's on inferential statistics. Which one of these guys do I use if I want to find a confidence interval for just a single proportion? Which one of those guys do I want?
One sample proportion.
Okay, agreed. Now, in this story, it was 150 successes. That's the top number, out of a sample size of 250. We hit the confidence interval, and that's the one I want, and it's 95, and I'm going to generate the result. And we got 53 to 66. So 0.53 to 0. I should call it 54, shouldn't I, from 2 decimal places, and finishing at 0.66. Now, if I want to do a 90%, doesn't it really mean I only need to change that one number, right? I don't have to retype everything. And I change that to 90, and I now say generate the results. And you see that it's now became, what was that for 50? 55 and 65. And then I'll do it one more time for 99. Oops, too many. 99. And if I generate that result, the answer we get is 52 and what, 68, if you round them off to two decimal places. Are you comfortable with how WebAssign takes all the strain out of the calculation, right? You just put in the numbers and you tell it what confidence interval you've got. That's what you need is there, right? Don't some of the other homework questions ask you for p-hat and standard error? And if they do, don't you just get the numbers p-hat, you get that number. If they ask you for the standard error, isn't it that number? So you don't even need to do any calculations at all now. So takes the strain. So let's return back to my question and kind of use this as our first guy. So here are three confidence intervals that we've calculated, and I'm going to put them in order. So here is 52, 53. I'm glad they came out quite nice numbers. 54, 55, 56, 57. Oh, shooting space. Let me do that again. I forgot I needed 68. So 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 67, 68, 68. There's 54, there's 56, there's 58. Okay, there might not be quite as symmetric as this would be, but you get the gist of it, right? There's your number scheme. And so I'm going to try and represent the 99, the 90, and all the other ones on this single number line. Right, a 90% confidence interval is 55 to 65. So 55 is about here, right? And 65 is about here, I believe. So the interval says that somewhere between 55 and 65, we are 90% sure that the real answer works. So this pill is effective probably with somewhere between 55 and 65% of the population. It's a pretty good market. Would you agree if 55 to 65% of the people who take it are going to say, yeah, that works, I'll take it again? That's a pretty good market on 90%. If we do the 95%, it grows a little bit. It grows from here to here. There's your 95%. And if I'd planned this out better, so I'll have to put it down here instead. That is your 99%. Do you see 90, 95, 99? Why are the intervals getting bigger in size as you increase your confidence level? Why would you think that would be necessary? Why would a 99% confidence interval have to be a bigger interval than a 90%?
Because it's including more of the actual population.
Right. And if you want to be 99% sure, don't you have to be a bigger interval to catch more choices? Does that make sense? We good? Now, in these situations here, you can then make some conclusions about how effective this is. Would you agree, no matter which one of these confidence intervals I choose, would you agree that there's evidence that the answer, the real answer to P, is definitely somewhere bigger than 50%? Would you agree all these numbers are bigger than 50%? So couldn't you honestly advertise and say that half the people who take this pill noticed an effect in the last, their headache went away in 30 minutes? Not sure that would be a good advertising ploy, but wouldn't it be true that at least half the people this pill is effective for? Now, if this was a pill to do with anything in medicine, you might think a 50% effectiveness rate isn't that great. Well, if it was cancer, and this pill was one of the possible treatments for, reducing the cancer or even eliminating it, wouldn't 50% be pretty good compared to no treatment at all, which is, death, right? So a lot of the treatments that we used in the past had quite low success rates, but isn't a low success rate better than no success rate? And then what they would do is that they, I worked with a person back in Scotland, and she worked for a research company, and they would looking into creating new drugs and so on, and she changed her career and went into teaching, and that's how I knew her. And she was saying that a lot of the times when they get any kind of success, it's like the starting point, and then they say, okay, what bits of this drug is actually the good stuff, and they try and strengthen it or they try and improve on it. And a lot of the early treatments in cancer had very poor success rates, but they did develop and get better. And then one of the most successful tricks, one of the most successful tricks in treating a lot of serious illnesses is that you don't hit it with one treatment, you put combinations. So you get chemotherapy and you take pills, and they can add in all sorts of things like change your diet, improve your exercise, holistic way of looking at things, and they can get pretty good successes. So that's very realistic kind of situation. So you get a story, you find a confidence interval, and then you say something about that confidence interval. In this case, I'm going to say that there is strong evidence that more than 50% effective. And I talked a little bit about increasing needs. So I think that was a pretty good question. Let's see where we are. Has anybody remember the last number we did, so I don't end up just talking about the same question again? Anybody got a recollection of which one we did last? Because I got a feeling it was pretty early on, but that's all I can say for sure. I know I did with my evening class, my later class. Did we do the one about lack of sleep? Does the story about lack of sleep seem familiar? No. Okay, let's go back. Did we do any of these questions then? Because maybe I'm actually thinking in my evening class. We did do some. So the early questions were, who's the population and who's the parameter, right? So, okay. So it looks to me like we should probably be starting our question right on the one to do with sleep. Okay. So it's going to involve me jumping about screens, and I don't know how I can. Oh, I have an idea. This probably won't work, but if it does, I'm going to be really happy. Okay, so you are going to tell me, please, that you can see both these screens at the same time. Was like, can you see both these screens at the same time?
Yes.
Whoa, we are on a roll here. Cool. Now, the only problem is that the writing's probably going to be really tiny unless you've got a really big screen. So you might want to just trust me when I say things, right? So in this question here, suppose that a new treatment for a certain disease is given to a sample of 200 patients, right? It's very similar to the one I've just did. The treatment was successful for 152 of those patients. So what would that be? 152 out of 200, right? Kind of like the question I just did. Assume that these patients are a representative of the population that has that disease. That seems reasonable. And it asks us to calculate p-hat and a 95% confidence interval, and then do a story connected with what that confidence interval does, right? So it's got the same theme that I've got. So I'm going to go over here and I'm going to go one sample proportion. And the number of successes was 152. And the number of trials was 200. And I'm going to do a confidence interval and I'm going to generate the results. And over here, we have the lower limit, which is this number, which is about, what, 70% effective. And below it, the upper limit, which is almost 82% effective. And p-hat, if I scroll a little bit, is 0.76. Are you comfortable about how nice SALT is? Right, you type in the stuff and the numbers are there. In this question here, since it's 3 decimal places, won't this guy round off to 0.8 becomes 1, and this guy, there's 9, actually stays as a 9. So what's your rounding off? Because WebAssign is kind of pernickety about that. Now it says write a sentence that interprets what we have found. So we are 95% confident that if the whole population with the disease received this treatment, the proportion successfully treated would be within this interval. Does that seem like a reasonable English version of what was going on there? Right. If you wanted to do, instead of a 95, if I did a 99, what would happen to that interval? Would it get bigger, further apart, or would it narrow down? If I did a 99 on this,
It'd get bigger.
it would. And if I did a 90%, wouldn't it get smaller? Now, doesn't that truism? It's true all the time. It doesn't not care what the story is. It doesn't care how many were treated or not, or where the p-hat is. It's 90, 95, 99, right? They always get bigger, right? As you increase your confidence interval. If you did 99.9, wouldn't it be even bigger? Right? It would get ridiculously big. Are we comfortable with that SALT question now? Okay, now I'm now going to return back to my notes for a little while. I think I'm going to keep that too. Did that 2-page thing work for you as far as visually, or is it too small to see what the heck's going on? Good for some of you. Okay, good. So let's keep that then. And let's talk about what's called the margin of error. So I'm going to have a story attached with this. So if you didn't know this, because it's actually not true, but tomorrow there's going to be an election for the President of Scotland, and the local newspapers are interested in predicting who's going to win. And so they go out and they ask a sample of 10,000 people, shouldn't you be impressed by 10,000? Agreed? That is a pretty major expensive sample. Most samples are about 1,000 if you do the ones on TV. And they went out there and they found out from that 10,000 people that 5,082 of them are going to vote for the Royalist Party, right? Whoever that is. Right? So is the Royalist candidate going to win the presidency of Scotland? That's the puzzle, right? Now, I'm going to save myself a little bit of time, and I'm going to put this information into WebAssign, and in particular into SALT. So though you can't see me doing this, I'm typing it in. So 5,082 and 82 goes in. It was out of 10,000 people. And we are going to do a 99% confidence interval. That's what we're asked to do. So I'm typing that in right now, and I'm generating the results. And the answer that we got was 0.495, and it finished at 0.521. And p hat was a little over 50%. It was 0.501. Let's make that percentages. So the Royalist candidate got 50.1% of the vote. And the confidence interval at the 99% level was that he is likely to get 49.5 up to 52.1% of the vote. And then the question that they would probably finish with is there enough evidence here to say that the Royalist guy is going to win? Will he win the election or not? Or is it too close to call?
I want to say that it's too close to call, but there's a chance you could win because that 49.5 could round up to 50%.
Your argument about rounding off is understandable, but can we assume that you're not allowed to round off? In which case, I like what you said at the beginning. And because you're not allowed to round off, isn't this too close to call? And the reason for that is, couldn't the right answer be 49.6 or 49.7? Isn't that in the interval? And confidence intervals only say that the right answer is somewhere in that interval, and any of the numbers in that interval is just as likely to be the real answer as any other number. So would you agree 49.6 might be the right answer? And if it is, doesn't the other guy win? We'll assume it's a two-candidate world. And if it was 51, he would win. But if it was 49.8, he would lose. So it's too close to call. Suppose you get two confidence intervals. What's going to happen to this interval if I do 90%? Would you agree it's going to get smaller? By that, I mean closer. Let's see how close is. So I'm typing in 90 right now. I'm generating the results. And we got 0.499. 997, oh God, I'll have to do all of them. And 0.5164. Oh, would you look at that answer? Would you agree that it is definitely shorter, right? It's a smaller interval. If you were a gambling man, technically, isn't it still too close to call? But isn't this like, there's probably going to be a recount because the answer is going to be, you know, within 20 votes, right? It's going to be so darn close to 50%, right? That he's probably going to win. So it still counts as too close to call. Are we cool? I was hoping, I think I should have tweaked that number. What I was hoping to do, can we pretend I did it, that at 90%, just pretend that the answer was 0.501 and 0.512, right? In other words, 50.1% to 51.2%. Can we just pretend that, you know, that's what we did get? Because what I was hoping to then say is, wouldn't he now be guaranteed to win? at least based on the evidence that we have. Because isn't this interval all bigger than 50%? So if that did happen, we would say, not that he's guaranteed, we can't guarantee anything, but wouldn't we say there's evidence he would win? So I guess the question should be, if this was the real answer, which it is, and pretend this was the real answer, how come you can change your mind depending on the confidence interval? Why is that allowed? Well, if I choose this confidence interval, couldn't I be wrong 10% of the time? If I choose this one, am I only going to be wrong 1% of the time? And so when we say there's going to be evidence that someone wins, I do not mean bet your house on it, that person's going to win. Because if you did that, wouldn't one of the 10 people in your street lose their house? Now, up here, you're good. I strongly suspect that many polls work on 90% confidence intervals than 99. And the reason why I strongly suspect that is, if you do 99% confidence intervals, isn't it far less likely you're going to declare a winner? And isn't it, for the most part, boring to say, oh, we've just spent a big chunk of money and we still don't know who's likely to win? Aren't you more likely to say, I've just spent a big chunk of money and I think candidate A is going to win? It's just a human nature thing that we don't like non-answers, right? We like to get an answer out of the question. Now, I'm going to talk still on margin of error, but a different kind of question. Suppose we already know that p hat is 0.34. Okay. And I tell you that the margin of error is 0.06. If you put those two guys together, can't you create a confidence interval? And let's say that you're told this was a 90% confidence interval that this information came from. Then wouldn't you take the margin of error and subtract it from 0.06 and the margin of error and add it to 0.06? And that would become, well, if you take that away, 0.28, and if you add that, 0.4. So as long as you know these two numbers, can't you make a confidence interval? Suppose I told you we conducted a survey and 32% of Olympic College students are left-handed. And I told you that the margin of error was 3%. Wouldn't you be able to then tell me the range of values that you would expect in the rest of America? It would be take away 3% and add 3%. Does that make sense? So if you're given a question where they basically just hand you what you need to know on the plate, it's not that difficult to create a confidence interval. And now we're going to return back to the homework and have a look at some of those kinds of questions that we've just finished doing. Cool. Okay. In a survey of 42% of randomly selected sample of 1,061 Americans, adults said, what did they say? That they don't get enough sleep. So it's a not get enough sleep people, right? And the margin of error was 3.2%, and that was for a 95% confidence interval. So you want to know what the range is? Isn't it going to be 42 take away 3.2 and 42 plus 3.2. You agree with that? And quick calculation in my head, 38.8. And if you add it, it's 45.2. Now, I didn't need salt to do that, right? Now, it then says, write a sentence to interpret what that looks like. So, with a 95% confidence, we can say that the population of all Americans or all American adults or all adults. Ooh, I should read the story here. This survey was American adults, agreed? So when I look at this choice, it's American adults, right? And it's going to be somewhere between that number again to that number. So we're basically taking that interval and just writing it down in a sense. We cool with that? Now, do you think that this sample could be used to estimate percentage of college students who don't get enough sleep? And I seem to remember that question. Agreed? That wouldn't. I don't think college students are likely to be identical to the rest of the adult population. Right? They're younger and they probably party too much or study too much. I like the studying too much one. Now, in question 8, isn't essentially the same kind of story? So I won't do that one. In question 9, let's read this one. Suppose that 200 different researchers, this isn't one I have got. So imagine you did something 200 times, right? 200 places around the world done the same experiment, and they done it with 500 individuals. And each one of them calculated their 95% confidence interval with the numbers that they had. And the guy in the other country did the same, and the person in the next side did the same. So you're doing this 200 times. If you did a 95% confidence interval, right? 95% of 500, good grief, my brain's not up today. 0.95 times 200 times is 190 of them. So about 190 of them, which is 95%. Wouldn't you get an interval that had the real answer in it? A 95% confidence interval, 95% of the time you'd be right. So what percentage of the time will you get it wrong? Agreed, 5%. So you went so, and won't that be the other 10? Now, why is that concept important? A lot of people unfortunately think, and you hear it all the time, oh, somewhere in Finland, they did a survey and they found out that people who took caffeine were having a higher incidence of heart disease than people who didn't, right? Let's just say that's the story. So the big newspaper article is, new research has found out that caffeine is bad for your heart, stop taking caffeine, right? Now that's only one 95% confidence interval situation, right? They created the data and they got an answer, more people, right? But couldn't somebody in France do it and get a different answer? Couldn't that guy in Finland be one of the 5% that's wrong? And God forbid, see if they did a 90% confidence interval, couldn't they be one of the 10 they got it wrong, right? Because at 90%, it's a 10th chance you got it wrong. And so you make decisions based on one particular survey or sample, and you treat it as if it's true, because it feels like it is, right? These people over in Finland, they've done everything right, but didn't they just get unlucky with their sample, right? They got the 10% time that they got it wrong. So how does things become knowledge in the community? Well, after the Swedish guys, after the Finnish guys do it, the French guys go and do it, right? And they conduct a survey and they collect data, and the British do it, and 4 hospitals in America do it, right? And they get a government grant and they do it some more, right? And they get a body of knowledge. And if you do it lots and lots and lots of times, won't you eventually come to the conclusion that if almost all of them say caffeine gives you a bad heart rate, right, or makes you more likely to have a heart attack, doesn't that now become a truism? But if you get the result is, well, some of them said it does and some of them said it doesn't, don't you get to that stage, well, it probably isn't that strong a reason, right? There's probably other things going on. I could do a, let's bring in a term that we haven't used for a while. I could do a lurking variable. Why do people who drink coffee have more heart issues than people who don't drink a lot of coffee or don't drink coffee at all? Give me a lurking variable for that.
Weight, depending on the sweetener they use.
Yeah, people who drink a lot of coffee might be overweight. Give me another reason, another lurking variable.
Lack of exercise.
Okay. How about this one? I'm not saying mine is better than yours. People who drink a lot of coffee probably drink a lot of coffee because they are stressed. And stress is not good for your heart. Couldn't it be just an indication of something else? People who drink a lot, don't they probably have psychological problems? They drink a lot to forget. Couldn't people who drink a lot have a lot of psychological problems? Does drink cause psychological problems? Or is drink just a reflection that they probably have problems? You see what I'm saying? Does it cause it, right? Does caffeine cause your heart issues, or is it a lurking variable? Those kind of conclusions are part of the process, aren't they? Just because you found something, you've got to figure it out. You've got to think it through. And here's one about getting bigger and smaller. We have done those. This is bigger and smaller, so I'm not doing that one. And now we're into, oh, great timing. I think we've got time to do 2 more of these guys. So I don't really care which one we pick. Let's do this one. Shrink it back. Suppose that, no, I've done a new disease one. Let's do a different one. This is interesting. Let's do this one. In a national survey in 2009, 56% of 1,100, so I'm writing this down, 56% of 1,100 randomly selected American what? Adults said that abortions should be legal under certain circumstances. Okay, so it's a classic are you in favor of abortion question, right? And they were asked, do you think that abortion should be legal under any circumstance, legal only under certain circumstances, or illegal in all circumstances? Okay. So that 56, they chose from the list of 3, the middle one, right? Under certain circumstances. Okay. Calculate a 95% confidence interval based on that. Well, we're going to hit a roadblock right away. The number I've got is 56% of 1,100. Well, I know this number here was 1,100. That there is 56%, but that doesn't make that number 56, does it? How do I find the number of people from that 1,100 who are in favor of abortion? I know it's 56%, but how do I get the number of people that is?
Would it be 0.56 times 111 or 1,100?
Yep, 1,100 thingy, yes. That's what I'm doing right now. And that ends up being 616. Does that make sense that just because you are told 56% doesn't mean you always have to use the number they give you. Don't you have to interpret that? Because Salt doesn't want to know the percentage. Doesn't Salt want to know how many out of? So I had to do an extra little calculation. Apart from that, everything is good. So I'll turn that into 95. I'll generate the results. And it's going to be this guy. I'll put that one in. And it's going to finish on this guy. And once I've done that, I will then go and make it 3 decimal places. So this guy rounds up to 1, and 3 decimal places, this guy stands as 9. So what's that about? Somewhere between 53 and 59% roughly. Good. And then they have a little sentence, which we'll talk about in a minute. But let's focus on this one for a second. I wish they'd given you a question something like this. Is there enough evidence to prove that the majority of Americans are in favor of abortion? Does that interval indicate that the majority of Americans are in favor of abortion? And I'm just saying evidence, not that it's guaranteed. 53 to 59%. Majority of Americans are in favor. No gut feelings? Yeah. I'm going to say yes. And the reason I'm saying yes is similar to the guy who won the election. If there were 2 candidates, the abortion candidate and the not abortion candidate, didn't the abortion candidate win because he's more than half the people? And isn't majority just means more than half? That's what I'm interpreting majority to mean. So yeah, so you could write an article saying the majority of Americans, you might want to qualify it, a slim majority of Americans are in favor of abortion. Now, let's see what the next part says. On the basis of this confidence interval, is it reasonable to say that more than half of them did it? Since the interval is completely above 0.50, it is reasonable to infer. Do you see how that answer, that's how you would answer that question. Now, in the survey, 17% answered that abortion would be illegal in all circumstances, and they want us to calculate a different confidence interval for that number. So if you wanted to do it for the anti-abortion people, right, wouldn't it be a 17%? And wouldn't I have to change my 616 to whatever 17% was, which is what I'm doing right now? And I would get a lot fewer people, 187. And generate results. And if we do this as a comparison, there's the first answer. And here is the second answer. That guy rounds up to 148. And the one next door to it is 190. Would you agree that in this case, it's clearly much smaller, which is reasonable? Couldn't I say less than 20% of Americans are against abortion in every situation? Would that seem reasonable? Why could I say that? Aren't all these numbers less than 0.2? So when you read articles and they say the majority of Americans are in favor of whatever, or less than 20% of Americans are in favor of something else, they're getting that information, right? That evidence from these confidence intervals. Right? And you can use a confidence interval like these in 2 ways. couldn't I say, for instance, that isn't it less than 60% of Americans are in favor of abortion? Right, look at this interval. Why could I say less than 60%? All the numbers in that interval are less than what value? If I say evidence that less than 60% are in favor of abortion. Aren't they all less than 0.6, which is what 60% is? Let me nip over to the white screen. I think it might help if I point, because it may be a visual thing. Let's suppose we got a confidence interval, let's say a 95% confidence interval, on the percentage of people who like pickles. Now, if you turn it into percentages, which works better in my brain, the percentage of Scottish people who like pickles is 13 to 37%. I could express that information in two correct ways. I could say that there's evidence that more than 10% like pickles. And how can I say it? Aren't all these numbers bigger than 10%? Would you agree? More than 10%, they're bigger. Can I also say that there's evidence that less than 40% like pickles? Would you agree? All of these numbers are also less than 40%. There's nothing magic about 40%. Couldn't I have said 38% and it'd still be true? And there's nothing magic about 10%. Couldn't I have made that 11% and it still would be true? So if you ever read an article and they say, oh, they've conducted some research and less than 40% of Americans are in favor of guns, right? They got it from one of these confidence intervals, right? And they just said, okay, are all the numbers bigger than this or are all the numbers less than that? I think that's a good place for us to finish then. I was going to do one more, but we can do this tomorrow. We've pretty much covered everything that's going to happen in that section. All we'll be doing tomorrow is, maybe a couple more of these, and then